Hey, today I wanted to cover Kubernetes security, cover most of the Kubernetes security side of things. To introduce myself, I am not quite blue teamer or red teamer, but I work as a DevSecOps in one of the company. So my day in day out job requires a bit of a security, embedded security. We pretty much look security as a part and parcel of pipelines. It has to be always security has to be always thought during the process, right? So yeah, in this video I'm going to cover 3 specific major topics, and we'll break it down to its own subtopics. So first topic is we're going to talk about how secure is Kubernetes by default and what we need to do. We will look into the transverse path. As in transverse path, we will refer to how Kubernetes or how misconfigured Kubernetes can allow an attacker to access or transfer sensitive part of the system, walking through the door and going into the different room, if you like. And then we will look into all of these components as a layers, right? So there are a bunch of different layers in today's cloud native Kubernetes setup. We'll look into those sort of things. Okay, so let's start with how secure is Kubernetes by default then. It is designed to be secure with every releases, with every changelog. If you look into it, there are security mindsets, there are security related fixes coming in, there are researchers working on Kubernetes internally, externally. You will see all of these gentlemen working for the good cause through the researcher companies or other personal interests. So that it gets better and better, but also there will be configuration side of things which will make things less secure as a default, right? So Kubernetes is designed with security in mind, but it's not inherently secure by default, if that makes sense. Kubernetes provides several features, several security features and mechanism, but then if something is very flexible, you can hardly make it secure, right? Security goes as in those 3 triangles, with usability and security being 2 point of the triangle. It is quite difficult, and it is a challenge to meet in the right at the middle, or if one point always wins the battle, right? And having in the middle is the right thing to do, but it's difficult. So it requires a proper configuration and management to ensure the secure deployment. If we have to look into default security posture, we should be talking about authentication and authorization in Kubernetes. We should be talking about network security side of things, how to manage secrets, service account side of things, pod security policies, and audit and logging. If there could be other aspects as well, but then if we divide, that could be a key division, right? Kubernetes provides a solid foundation, but it is essential for administrators to understand and implement additional security to get the best out of it. Right? There are CIS compliance benchmarks, there are Aqua projects, there are lots of other different projects to make things more secure. I'll try to cover as I can. Right? So if we look into authentication and authorization side of things, Kubernetes implements the basic authentication and authorization mechanism, but these are not enabled by default, or it is enabled, but then it will not be that granular in some cases. Administrators need to configure RBAC, like role-based access control, to restrict access to the Kubernetes API, and then RBAC does not follow a deny allow path, so it can be tricky. Network security, Kubernetes doesn't enforce network security by default, leaving pod open to communicate with each other. So the network isolation, the namespace isolation, these sort of things are the enforcement that you bring with the likes of Calico or CNIs. That is another part. Network security default posture is not enough. Secrets management, again, secrets are like base64 encoded by default. It's not encryption, right? It's encoding and easily decoded, right? It can be easily decoded. So the built-in mechanism called secrets for storing sensitive information, not good enough. And then there is a default service accounts. Kubernetes creates the default service accounts for pods to access the API server. Administrators should review and limit the permissions those default service account has. Other one would be pod security policies. Kubernetes doesn't enforce pod PSPs, right, by default. PSPs coming from 125. Now, is it 125? 126? I could be wrong. I'll have to double check it. By default, it's not enforced until 125 or until really recent version. Now PSPs are enforced. Audit logging. Kubernetes supports audit logging, but then again, it's not enabled by default. Administrators need to configure audit policies. So overall, Kubernetes provides a foundation for building a secure, containerized environment. It is really essential for administrators to understand and implement additional security measures. With the cloud coming into action, with the cloud vendor coming into action, there are those elements that you have to do extra sometimes, but sometimes you also get it from the part of the shared responsibility model. Cloud gives you some benefit as well. So now let's talk about Transverse Path, right? How exactly attackers can walk through the channels so that we can talk about where and what to implement. In Kubernetes security, a transfer path would be a vulnerability that allows attacker to access or walk through the sensitive parts of the systems that they shouldn't have access to. So for instance, we can if we divide that into a few key, it would be pod mount path, Kubernetes API, insecure container images, volume path, secrets, misconfigured RBAC, or container runtime as well. So from a pod mount path perspective, if a pod allows mounting of a host directories or volumes without a proper restriction, an attacker might exploit this to traverse the directory structure of the host node and access the sensitive data that way. Kubernetes API path would be insecure configuration of Kubernetes API access, could lead to, again, privilege escalation, data breaches, sort of thing. And insecure container image, pulling insecure container image from untrusted registries, or not knowing what you are pulling. And it is a difficult bit, right? Today, getting all of these third-party tools, getting all of these tools, and not knowing what exactly is coming. If there is a malicious code, that can be a big blow too, and that could lead to a potential security breach. Volume path transversal is another topic here. If Kubernetes pod mounts up volume from a network storage system like NFS without a proper access control, an attacker might transverse the data, the directory structure of the storage system, and access or modify unauthorized file or directories too. Another one to look into would be insecure secrets path. Same again, misconfiguration, improper handling of the secrets can lead to that. RBAC is the big one. Misconfigured RBAC can lead to the biggest blow, I would say. If attacker gets an access to a lowest possible role and finds a way to escalate the privilege, gain an unauthorized access to perform some sort of actions, which we call as a verb in RBAC world, that can be a blow too. They should not be allowed to do that. Container runtime, insecure configuration for the containers runtimes like Docker might allow attackers to transverse the path. To mitigate all of these things, to mitigate the transverse path vulnerabilities, we got to follow the security best practices, implement the least privilege principles, ensure proper access control, regularly update and patching, stuff like that. Right? Let's look into all of those things that you have to look into from a layer perspective. Where we will also touch on the best practices, how transfers can be stopped, right, and how we can implement the proper security measures. So if we look Kubernetes from a layer perspective, we can divide it into infrastructure, control plane, data plane, container, network, and resource policy, right? So infrastructure, when we talk about infrastructure, it is pretty much like underlying infrastructure. So ensuring the underlying infrastructure, like servers, networking attached with the servers, virtual machines, right? We need to ensure those are secure by following the best practices or guideline from a cloud security or on premises. And let's talk from general today's 80-20 within the cloud being mostly used. And we talk about cloud security. So if we are talking about these big giants, and let's take for instance take an example of Amazon. So you would want to follow the best practices from Amazon for underlying infrastructure. Again, benchmarks that Amazon provides, trusted advisor guidelines and stuff like that, right? Because if we take an example of Amazon, which is just an example, it will be same for any other on-premises or any other cloud provider. Second thing would be control plane layer, right? So from Amazon perspective, we should be talking about EKS patches and upgrades. Similarly, Azure AKS, Google GCP, or on-premises if you're managing yourself. Again, the patches and upgrade, same thing for everyone, right? So regular patch and upgrade of clusters to ensure that they are protected against the known vulnerabilities. And given that Kubernetes is upgraded every 3 months, you have a bunch of fixes there, and you got to stay up to date. And I normally like to say N-1 would be the best place to be. If today Kubernetes is in 130, you want to be in 129. 130 is about to be released, so I'm giving you this example. But again, just to give an example of N-1, right? And another layer would be data plane. So data plane security, if you're using managed services like EKS, you got to ensure that nodes are regularly updated. You may be using host machines like Amazon Linux or CentOS, whatever you are using it. Those host OS needs to be patched and updated regularly to address the security vulnerabilities. And cloud provider offers like tons of automated solution for these, so it should be pretty relatively easy. But then again, you want to run your own tools around the data plane layers as well. So maybe if you're working in companies like of Tanium or CrowdStrike, or those kind of tools are there in the market which does the host level scannings, right? Another layer, if we divide, the fourth layer would be containers. And container scanning is quite crucial, right? We previously touched upon insecure container path as a transversal method, where if you pull the insecure images, you could be in trouble. So how can we ensure that is through the container scanning? So integrating a container scanning into your CI/CD pipeline to identify and remediate vulnerabilities in order to be secure from a container's perspective is the key thing. There are a bunch of tools, right? There are a bunch of tools like Claire, Trivy, Anchor, Prisma Cloud, right? Previously known as Twistlog. You could leverage these kind of tools, and then these tools can be, while a developer builds the image, when it gets backed into any of the environment via CI/CD or through the CI/CD, or it could be running within the cluster as well and constantly reporting back the data. Network policy layer, network policy enforcement is another crucial thing. For the isolation, this is really important. Multi-tenancy would be really, multi-tenant applications should be really looking into these kind of things as well. So choose a network policy such as Calico or Weave or container network interface to enforce network segmentation and control traffic flow between the pods. So defining this network policy is really necessary. And there has to be, or there should be, there must be the block on the unauthorized access. Last one, if I layer this, it could be a resource policy layer, right? So resource policy enforcement would be likes of OPA, Open Access Policy Agent, or Kyverno, to ensure the resource policy at the runtime. With Kubernetes 130, there are some other features coming in as well around the policy layer, is typically around the resource policy. We can make another video on that, which deserves another video. It's a big topic. These policies can govern like various aspects of Kubernetes resources, like pod security, quota security, labeling standards, compliance, any other organizational security requirements as well. It can be super customized. We can see some of these examples in here on resource policy layer, and all of these components I'll attach links in description around what can be looked, and each layers and each breakdowns providing a link towards. And then if you want us to cover anything in a specific, give us a comment and we'll come with a video more generic towards that subject. These are huge topics, right? This security is huge topic and it's a major concern. We will be coming up with videos around each of these topics. If you want to get us going with some specific topic that you're looking into, so you want us to deep dive, let us know in the comment section. And by considering this security measure at each layer, you can create a robust security postures, and it's not could have, would have. These should be looked as a must have and should have implementation. Yeah, that's it for now. Thank you very much for staying with us. Help us improve our knowledge sharing by giving us feedback. Thank you very much.